Welcome back. In today's video, we will be learning how to solve problems involving the length, midpoint, and gradient of a line segment. This is a key concept in coordinate geometry and will help you tackle a variety of geometry problems with confidence. Before we begin, make sure you are comfortable with finding the length, midpoint, and gradient of the line segment when given two coordinates. You have already done this concept in O-level or IGCSE mathematics. Let's do an example of finding out the length, midpoint, and gradient of the line segment. P is the point 4, 5 and Q is the point -4, -1. Find the length of PQ. Formula for taking out the length of PQ is under root x2 minus x1 whole square plus y2 minus y1 whole square. The coordinates are 4, 5 and -4, -1. We can consider this as x1, y1 and this one as x2, y2. We will substitute these values in the formula. So PQ is equal to under root -4 whole square plus -1 -5 whole square is equal to -8 square plus -6 square. So we have got here 64 plus 36, which is equal to square root of 100. Square root of 100 is 10. Now we will take out the midpoint of PQ. Formula for midpoint of PQ is x1 plus x2 upon 2, comma, y1 plus y2 upon 2. You will substitute these values in the formula. 4 minus 4 upon 2, comma, 5 minus 1 upon 2. We have here 0 upon 2 and 4 upon 2. Finally, we have coordinates of midpoint are from 0 till 2. If we have a line segment AB whose coordinates are A 4, 5 and B -4, -1. Length of the line means that we have to find the distance from A to B. Midpoint is the point which is in the center of these 2 points. So midpoint is to be over here. Now we will do gradient of PQ. Formula for taking out gradient is y2 minus y1 upon x2 minus x1. And we denote it by m. So we can take out gradient of PQ by substituting the values in the form. y2 is -1 and y1 is 5. So -1 -5 upon x2 minus x1, which is minus 4, which is equal to minus 6 upon minus 8. So finally, we have 3 upon 4 as gradient of PQ. Let's do some questions related to length, midpoint, and gradient of the line segment. We have P minus 7 comma 8, Q minus 1 comma 4, and R 5 comma 12. Calculate the length of the sides of the triangle PQR. Use your answers to determine whether or not the triangle is right angled. So first of all, we will find out the lengths of PQ, QR, and PR, which are the sides of the triangle PQR. So PQ is equal to, so the length of PQ is equal to x2 minus x1 minus 1 plus 7 whole square plus 4 minus 8 whole square, which is equal to minus 1 plus 7 is 6, and 6 square is 36. 4 minus 8 is minus 4, and square of minus 4 is 16. So the length of PQ is under root 52, or we can write it as 2 under root 13. Now we will take out the length of QR, which is equal to 5 minus 1, 5 minus minus 1, so which is 5 plus 1 whole square, and then 12 minus 4 whole square, so we have here 5 plus 1 is 6, and 6 square is 36, plus 12 minus 4 is 8, and 8 square is 64. So we have square root of 100, which is equal to 10. Now we will take out the length of PR. PR is equal to square root of 5 plus 7 whole square plus 12 minus 8 whole square. Then we have 5 plus 7 is 12, and 12 square is 144, plus 12 minus 8 is 4, and 4 square is 60, which is equal to square root of 160. We can write it as 4 under root 10. We have done the first part of the question. Now, second part says use your answers to determine whether or not the triangle is right angled. If we have to prove that this triangle is a right angled triangle, then we have to use Pythagoras theorem. And according to Pythagoras theorem, the square of the longest side, which is hypotenuse, is equal to the sum of square of other two sides. So here the longest side is this one, So square of PR is equal to PQ square plus QR square. PR square we can simply take under root 160 is equal to PQ square under root 52 square plus under root 100 square. As we know, we have to take square. So that's why we have taken here the numbers which are in under root sign and radical sign. We can cancel out the square with this square root. So we are left with 160 is equal to 52 plus 100. 160 is not equal to 152. So we can say it's not a right angle triangle. Next question. Coordinates of A, B, and C are given, and we have to show that triangle ABC is a right-angled isosceles triangle. So first of all, we will take out the lengths of AB, BC, and AC. For length of AB, we'll be using the coordinates of A and B. So we have here 1 plus 1 whole square plus 6 minus 0 whole square, which is simply 6 square. So we have 1 plus 1 is 2 and 2 square is 4. 6 minus 0 is 6, so 6 square is 36. So we have here under root 40. Now we will take out BC, for which we have to use the coordinates of B and C. Seven minus 1 whole square plus 4 minus 6 whole square. So we have 7 minus 1 is 6, 6 square is 36. 4 minus 6 is minus 2 square is 4. So we have here as well under root 40. Now we will take out the length of AC. So AC is equal to square root of 7 minus 1. So it will become 7 plus 1 whole square plus 4 minus 0 whole square, which is simply 4 square. So we have here 7 plus 1 is 8. 8 square is 64 plus 4 square is 60. So finally, we have square root of 8. Two sides are same, so we can say that it is an isosceles triangle. Now we have to check whether it is right angle or not. These two sides are same and this is the longest side. So it means that here as well, we will use Pythagoras theorem to prove that whether it is a right angle triangle or not, for which we will see which is the longest side. The longest side is AC. So AC square is equal to AB square plus BC square. AC is under root 80 square. AB is under root 40, so under root 40 square. BC as well under root 40, so under root 40 square. We can cancel out the square with square root. So we are left with 80 is equal to 40 plus 40. 80 is equal to 80. So we can say that ABC is a right-angled isosceles triangle. Next question. Now the distance between 2 points P 10, 2B and Q B, minus 5 is 5 under root 10. We have to find the possible values of B. As the distance between 2 points is given, so we can use here the distance formula in which the distance is already given. So 5 under root 10 is equal to under root x2 minus x1 b minus 10 whole square plus minus 5 minus 2b whole square. We have square root sign here and here 5 under root 10. So remove the square root sign. We can take square on both these sides. When we will take the square here, 5 square is 25 and square of under root 10 is 10. So it is to be 25 multiplied by 10, which is equal to, we have b minus 10 whole square. We have to use identity to expand this. B minus 10 whole square is b square minus 2 into b into 10, which is 20b, plus square of 10, which is 100. We'll use here as well, we will use identity to expand it. Whenever we have two negative signs, we will get all the signs positive. So we have 25, 5 square is 25, 2 multiplied by 5 and then by 2 is 20. So 20b plus square of this 2b, so it is 4b square. Now minus 20b and plus 20b would be cancelled out. We will be left with 250 is equal to b square plus 4b square is 5b square. 100 plus 25 is 125. Now 250 minus 125 is 125 is equal to 5b square. 125 divided by 5 is 25. So b square is equal to 25. And then we will take square root on both sides. So we will get b is equal to plus minus 5. Now we will do properties of some shapes: square, rectangle, rhombus, parallelogram. Diagonals of square, rectangle, rhombus, and parallelogram meet at midpoint. Like if this is the rectangle A, B, C, D, then the diagonals are AC and BD. The midpoint of AC and the midpoint of BD, they meet at this point, right? Whatever the midpoint of AC, it is equal to the midpoint of BD. And we use this property to find out the coordinates of the fourth vertex. We will do the question related to this. These are the shapes whose diagonals meet at 90 degrees. Square, rhombus, and kite. You can see this is kite. If we write here A, B, C, and D, AC is the longer diagonal and BD is the shortest diagonal of this kite. In kite, these two sides are equal and these two sides are equal. The diagonal AC intersects the diagonal BD by making an angle of 90 degrees. Same is the case in square and rhombus as well. Their diagonals meet at 90 degrees. So you must have all these properties in your mind while doing the questions related to coordinate geometry. Now we will do a question related to the concept of midpoint of AC is equal to midpoint of BD. Three of the vertices of parallelogram ABCD are A minus 7, 6, B minus 1, 8, C 7, 3, and the coordinates D, which we have to take out in the next part. So we can consider these coordinates as X, Y. First of all, we have to find the midpoint of AC. For coordinates of midpoint of AC, we have to add the coordinates of X, divide by 2, and we will add the coordinates of Y and divide by 2. 6 plus 3 divided by 2. So we have here 0 divided by 2 is 0, and 6 plus 3 is 9, and 9 divided by 2 is 4.5. So the coordinates of midpoint of AC are 0, 4.5. So now we will take out the coordinates of D using the midpoint of AC. Midpoint of AC is equal to midpoint of BD. Midpoint of AC is 0, 4.5. We have here X and we have here minus 1. So X minus 1 upon 2, comma, Y plus 8 upon 2. Now we will equate X coordinates to find out the value of X. So 0 is equal to X minus 1 upon 2. So 0 multiplied by 2 is 0. So X minus 1 is equal to 0 and X is equal to 1. Then we will equate Y coordinates. (4.5) is equal to Y plus 8 upon 2. This is the coordinate of X, and here X minus 1 upon 2. Here 4.5 is the coordinate of Y. Here Y plus 8 upon 2. So we have to equate 4.5 to 5Y plus 8 upon 2. So we have here 9 is equal to Y plus 8 and Y is equal to 9 minus 8, which is 1. So the coordinates of D, are 1, comma 1. Another question in which the point P 2k comma k is equidistant from A minus 2 comma 4 and B 7 comma minus 5. Find the value of k. Equidistant means at equal distance. So P is at equal distance from A and B. We have to take out the value of k, the constant. As we know, the distance from A to P and the distance of B to P is same. So we can write here AP is equal to BP. On this side, we will take out the AP, the distance from A to P, and here we will take out the distance from B to P using the distance formula. So here from A to P, we will do minus 2 minus 2k whole square plus 4 minus k whole square. For distance from B to P, we will use the coordinates of B and P. 7 minus 2k whole square plus minus 5 minus k whole square. As we have here square root signs on both the sides, so we can cancel out both the square root signs, or you can say that take square on both sides. If you'll take square on both sides, both the square root signs will be cancelled out. We have to expand these brackets. As we know, there are two terms and there is a square on it, so we have to apply identity to expand. Both the signs are negative, so all the signs in the expanded form will be positive. Minus 2 here, we will take square of 2, which is 4. We'll multiply 2 by 2k, which is 4k, and then multiply it by 2, which is 8k. Take square of 2k, which is 4k square, plus 4 square is 16. 4 into k is 4k, then multiplied by 2, 8k, minus 8k, k square is equal to, we'll expand these as well using identity. 7 square is 49. 7 multiplied by 2 is 14, and 14 multiplied by 2 is 28, so it is minus 28k. Square of 2k is 4k square. Then plus square of 5 is 25. 5 into k is 5k, then multiplied by 2, that is 10k. Then plus k square. We'll simplify both the sides. 4k square will be 5k square. 4 plus 16 is 20. And 8k and minus 8k will be cancelled out. On this side, 4k square plus k square is equal to 5k square. Minus 28k plus 10k is minus 18k. 49 plus 75 is 74. 5k square and 5k square will be cancelled out. We will take minus 18k on this side, so it will become 18k. We will take 20 on this side, it will become minus 20, and 74 minus 20 is 54. So the value of k is 54 divided by 18, which is 3. Let's do some past paper questions related to the concept which we have done over here. The points A and B are minus 8, 8 and 4, 0 respectively. Calculate the length of AB. We have to use the formula for taking out the length of AB. We have here x1, x2 and here y1, y2. So x2 minus x1 is 8, 4 plus 8 whole square plus 0 minus 8 whole square. We have to write it in under root sign. So AB is equal to 4 plus 8 is 12 and 12 square is 144. 0 minus 8 is minus 8 and square of minus 8 is 64. So finally, we'll get here 208. You can write the answer as it is, or you can write it in decimal, or you can write it in simplified surd form. Simplified surd form for this is 4 under root 13. And the decimal form of this is 14.4. Rounded off to 3 significant figures. Another question related to midpoint. The points A and B are minus 2, 6 and 6, 10 respectively. Find the coordinates of M, that is the midpoint of AB. So we have to use here midpoint formula. Midpoint is equal to x1 plus x2 upon 2. So minus 2 plus 6 upon 2, comma, y1 plus y2 upon 2, 6 plus 10 upon 2. Make sure you are writing in bracket because we have to always write coordinates in bracket. Minus 2 plus 6 is 4 and 4 divided by 2 is 2. 6 plus 10 is 16 and 16 divided by 2 is 8. So 2, 8 are the coordinates of M, the midpoint of AB. Next question is the points A and B have coordinates P, 3 and 1, 4 respectively. Given that the gradient of AB is 1 upon 3, find the value of P. Here, gradient of AB is already given and the coordinates of AB are given, which are P, 3 and 1, 4. So we will consider this as x1, y1, x2, y2. Gradient of AB is 1 upon 3. It means M of AB is equal to 1 upon 3. We will take out gradient using the coordinates given in the question so that we can take out the value of P. y2 minus y1 is 4 minus 3. x2 minus x1 is 1 minus P, which is equal to 1 upon 3. 1 upon 1 minus P is equal to 1 upon 3. We will do cross multiplication. 3 is equal to 1 minus P. We will take P on this side. We will take 3 on that side. So 1 minus 3 is minus 2. So the value of P is minus 2. Just a quick recap. The formula for taking out the distance between 2 points is under root x2 minus x1 whole square plus y2 minus y1 whole square. Gradient of line is a y2 minus y1 upon x2 minus x1, and midpoint of a line segment is x1 plus x2 upon 2, y1 plus y2 upon 2. Other than that, you must remember that whenever you have to prove that the triangle is a right angle triangle, we have to use Pythagoras theorem. And for an isosceles triangle, you have to take out all the sides. If two sides are equal, then it means it is an isosceles triangle. Then you must remember the properties of different shapes so that you can easily do coordinate geometry questions. The midpoint of AC is equal to midpoint of BD for square, rectangle, rhombus, and parallelogram. For square, rhombus, and kite, the diagonals meet at 90 degree. You must remember what is equidistant. Equidistant means the point which are at the same distance. Keep practicing these types of problems to master coordinate geometry. If this video helped you, don't forget to like, share, and subscribe. And make sure to check out more content on coordinate geometry and other topics. Thank you so much.